This is example number 1 from chapter 9. Here we have a city that is with a radius of 0.060 meters. Their spins are 7,200 revolutions per minute. And they're asking us 3 questions. What is the city angular velocity, W, in radius per second? How much time is required for it to rotate through a 90-degree angle? And if it is started from rest and reaches full speed in 4 seconds, what is the average angular acceleration? I did a free body diagram that is here, and then this is to find the angular velocity. W equals to the 7,200 revolutions over 1 minute times 1 minute per second times 2 pi radians over 1 revolution. All this is to find the angular velocity in radians per second. When you do all the calculation, it gives you 754 radians per second, and this is the angular velocity, like I said. Now, to find, we use this equation. W equals to delta to the change in the angles and the change in time, to find the time. And then we rearrange this equation, so delta t is equal to delta angle over W. The angle is 90-degree angle. We're going to convert to radians because the velocity is in radians, so it's pi over 2 radians over the angular velocity, 754 radians over seconds. The radians, we cross out the radians, so the time that required for the city to rotate through the 90-degree angle is 0.0021 seconds. Now, to find the average angular acceleration, we're going to use these equations. Is this equation, so it's going to be 755 radians per second over 4 seconds, because it's delta W over delta T. It's gonna give us 189 radians per second squared, and this number is the average angular acceleration. And this is how you solve the example 1 from chapter 9.